Okay, hi guys. Yesterday I missed to upload the video because of fever. Today also you can recognize fever in my voice. Okay, I'll start and I'll continue the 12th, yes, 12 days, uh, some things like that. Because in the 12th day we studied about how to pre-process images. So in this video we are going to study. We left at the time we get over. Sorry, I forgot to, we will see those things. Overfitting. After overfitting, we left that and we use Keras data to input the things. In this video we are going to study about image classification, and finally we will upload our image and check whether it can predict our image or not. Okay, I will start. Okay, after this, I get some suggestions from others. So they told me to make videos in English. So after that, I decided to make videos in English. So keep supporting me, guys. Also, if I make some mistakes, please please tell me and give your feedback. That's the important thing for me. Then only I can grow. Okay, we will start. Okay, okay. If I am hard to explain something in English, I will use Tanglish. What is Tanglish? Tanglish is it's combining some Tamil words with English. That is I call Tanglish. Okay, we will see. Image classification. This tutorial shows how to classify image of flowers using TF-Keras sequencer model and load data using TF-Keras util image data from directory. In the previous video, we study another method, tf.data, and also this is also in this method we studied that we get some overfitting. So in this video, we are going to see how to eliminate those overfitting, and finally we will we will get our model. Okay, it demonstrate the following concepts: efficiently loading dataset of disk. Okay, identifying overfitting and applying techniques to mitigate it, including the data augmentation and and dropout. That's what I previously told also. Identifying the overfitting and applying techniques to mitigate. We will get the overfitting, so we want to apply some techniques and we want to mitigate those things. Okay, this tutorial follows a basic mechanics. Sorry, this. Sorry, guys. I'll sometimes I have fever, so sometimes I trouble. So don't care. Don't take this tutorial. Flowers are bay. This tutorial flowers are bay. Sorry. This tutorial follows the basic machine learning workflow. Examine first. We want to examine the understand data. Examine and understand the data. Next, we will build an input pipeline. I think yes, we will build a pipeline using this one, this Keras utils, and after that build a model, train the model, test the model, yes, improve the model and great repeat the process. Yeah, I think in this one we are going to eliminate and we are going to drop out, we are going to use augmentation and dropout and uh, mitigate the overfitting. Okay, we will see. In addition, the notebook demonstrate how to convert a save model. Okay, in this video, we are going to study new thing. That one is how to convert and save model. We are going to convert and save model, and also we are going to convert it to TensorFlow Lite and a model for TensorFlow model for on-device machine learning on mobile ML and IoT device. We are in TensorFlow Lite is the one we are using in IoT devices and other we are the edge devices like that. TensorFlow is a little bit high. We need to use more processing power, so they have another version TensorFlow Lite. Then we can use it to um, low CPU bar like that. So we can use using TensorFlow Lite model in our mobile phone, and I think some videos they have how to using in Raspberry Pi and also for our mobile phone. And also I saw somewhere they are using that one in ESP also. Okay, I forgot to minimize my video also. Okay, I will. Okay, I'll minimize the video. We will continue. Okay, first we want to, as usual, we want to load our wanted libraries, import TensorFlow and other necessary libraries. Okay, first, sorry, import the matplotlib as a plot. Wait, I want to drink some water. Okay, okay, first one is matplotlib pyplot as a plot. We know what is this. This is for visualizing graphs and those things. NumPy for mathematical equations and those things. Below, this one is for load images. TensorFlow as a tier. We know that one. Okay, Keras is the API. These are layers and sequential model. Okay, download and explore the dataset. This tutorial uses a data set of about 370, 3700, 3000, sorry, 3700 photos of flowers. The data set contains 5 subdirectories, one per class, which means they have a subdirectory flow in flowers photo folder. They have subdirectories, each one for each flower class. So in the flowers roses photos are under the roses folder. Like that, they have arranged those things. So first we want to pathlib. Pathlib is using for what? In previous video also we saw that to load and load the directory, those things we are using pathlib. I already compiled all the codes. Yeah, using run or I compile all the things. So they have output also. Okay, first one is we are the direct URL for dataset. Second, what we are doing, we are unzipping. Yes, extract the folder through. And the third one is we are what we are doing here. Okay, we are copying this directly to those things to our our disk. Those are these lines. After downloading, you should know now have a copy of this dataset table. Okay, there are 3670 total images. Okay, we can image count. Okay, using length list. If we saw these things in last video, it seems like for me. Yeah, we saw these things in last video also. Right? Where we are in here, not this one. Pre-load, image load and pre-processing. Image load and pre-processing. Yes, yes, we also the same thing. Yeah, this is the same thing in the last video. Last what we saw in pre-processing video. Okay, we are uh, counting the length of .jpg files. I have a coughing also, man. That's what hard to speak. Okay, I'm going to record this video. Okay, so this using we are getting the JPEG using data directory.global. After that, we get this list, and using the length, we can count all the things in that list. Okay, the length. Am I edited something? Yes, length. We are getting the how many letters, how many photos are in this folder. Okay, they have 3670 photos. Okay, after that, roses list. Okay, roses in this directory, which means yes, roses under roses photos are under process directory. So we are getting that directory as a process. After that, I am getting the first index in the process, which means that this is the first photo of process. To preview the photos, we are using pillow.image.open. After that, I'm getting that photo. In the first video, we are using matplotlib. We are preview the image using graph, which means we are change the image to array, and after that we preview that array shape in matplotlib, so we are able to show the image like that. But this one is directly as we are previewing the image. If I change this to 2, we can get second image of rose. Yeah, second. I don't know how many images there, but we will check whether they have 100 flower. Yes, these are flowers follow. Okay, why? Yes, in below one also we are showing the first index. We can check 55th image like this one. This is just a index man. Yeah, these are the process image. After that, yeah, after that we are using what is this? Tulips. I don't know what is tulips. What is man tulips? I have no idea. Is this tulips or tulips? We will check. What this? Tulips or tulips? Tulips or tulips? Yeah, yeah. But it's not going to be meaning. Then it will read. Yeah, man. Tulips. Tulips, yes, tulips. Okay. After that, there another. We are seeing another image also. I'm going to change this one to 30. Where is the flower in this photo, man? I think they have photos. Something. Okay, we will read other things. Load data using KRS utilities. Next, load these images of disk using the helpful Teras this one utility. This will take you from a directory of image on disk to a TF dataset in just a couple line of code. If you like, you can also write your own loading code from Sketch by visiting the load and preprocess tutorial. Yes. In this video, what we are going to use is this one. This using what we call this method. In the previous video, we show they have two methods. One is this one, and the another one is tf dot data. So in this video, we are going to use this one, and we will model our model. We'll train our model. So data set. Define some parameters for loading. Okay, batch size is how much we are splitting to train our data. That one is page size, image height, we know, don't want to tell image width also, we know. It's good practice to use a validation split when developing a model. Use 80% of image for training and 20% of validation. Okay, these all are in previous order video also show these, shown this, explain these all things meant. Okay, okay, it's okay. Data directory, where is the data directory? Validation split. Subset is training seed. Seed is one, two, three. The seed is we are using seed for get random data. Which one? Same random data, which means if we get the random using seed, same seed, we will always get the same random like that. That's what I think here. Seed. Okay, we will check. I will ask Jenny. Jenny. What is seed here? Seed. What? What's seed? Seed. The seed parameter is initialize the random number generator. Yeah, that's what I also said. Okay. Found 3065 belongs to 5 classes using files for training. Okay, which means this is the 80 percentage of flowers for training and the remaining for validation. Yes, this is the training set now. Yes, this is the training data set. After that, the same things we are going to split for validation data set. Here the subset is changing. In here training, in here we are going to validation. We are going to put this one for validation. Other things are same. Okay, this is the 25% of 3670. Okay, you can find the class name in the class names attribute on the data set. Okay, these corresponding to directory names in the alphabetic order. Okay, okay, we just using a data set and class name. We will get the class names. They have 5 class names. Okay, okay. Now we are going to visualize the names. Yeah, here we are. Here are the first 9 images from training data set. Okay, we are using why again we don't we don't need here in here again need here because we already assigned it that one in first line. Yeah, man, here. Yeah, we don't need again that one. Why we not? Why we want to write code it again? Okay, what we are going to do is first we want to plot the figure is 10 into 10, which means the full image, full this one is 10 is 10 into 10 is to 10, 10 into 10. Okay, after that, for image labels in dataset, train dataset, take 1. Okay, for I in range 9. Okay, now we are going to display 9 images. Okay, each one 3 into 3, like that. Okay, here we are using uh, plot, which means yes, so yes, in here just we are plotting image using matplotlib, and yes, this one is for plot the image, and this one is for these labels, which means this for Dendalian clips something. And this one is plot axis of, which means if we plot without this one, we will get x-axis and y-axis. If we use this one, we can hide those things. Okay, next you will see, you will paste these data set to the Keras model fit method for training data in this tutorial. If you if you like, you can also manually iterate over the data set and retrieve batches of images. Okay, what we are going to be doing? Okay, for image. Okay, previous video also saw these things. Right? Here, this one is 32 is 32 images, 180 into 180 pixels, 3 is for RGB color, 32 is 32 labels. Okay, the image batch is a tensor of shape. This is batch of 32 image of shape. Yes, 180 to 183. The last dimension refers to color channel RGB. The label batch is tensor of the shape 32. These are corresponding label to 32 images. You can call NumPy on the image batch and label batch tensor to convert them to NumPy array. So convert those things to NumPy. We can call this one NumPy.NumPy. Then it will convert to NumPy array. Okay, configure the dataset for performance. Make sure to use buffered prefetching so you can yield data from disk without having input-output become blocking. These are the two important methods you should use when loading the images. Okay, if you want to, when we import the dataset, we want to eliminate the bottlenecks, which means I think I will explain somewhere. Yeah, man, bottleneck. Okay, yes, like this one. This one, bottleneck. If we get large amount of data, here the input, this one is narrow, so we can't get it properly. So we will get stuck here. That's what is bottleneck problems. To eliminate those things, we are using dataset of cache or prefetch. Prefetch. Here I think we are using cache. Yes, cache. Yes, all of data pre-processing and model executor while training. This will keep the image in the memory after they are loading off disk during the first epoch. This will ensure the dataset does not become a bottleneck while training a model. If your dataset is too large to fit into memory, you can also use the method to create a performant on disk cache. Okay, autoline, which means it will automatically take how much cache we will need. That's what is auto tune. Sorry, auto tune. Auto tune. Okay, we will get training data set. We'll cache training data set and validation data set. After that, standardize the data. Okay, I will roughly go through these things, man. Previous video, every video we are speaking about these things. I can't. I'm bored about this. Now I'm bored. Yes, seriously, I'm bored. Boring for me. Okay, now first, if you want to normalize the data, we are divided by 255 because the RGB range is from 0 to 255. To get the scale between 0 to 1, we are going to divide this by 255, then we will get 0 to 1. Okay, after that, what we are doing, normalize the data, and normalize. Okay, what we are doing here, there are two ways to use this layer. You can apply it to dataset by calling dataset map. Okay. I think yes. Here we can normalize using dataset map. Otherwise, we can normalize, which we can we can initialize the normalization within the model also. I think that's one is the best way. You can that's all. Or you can include the layer inside your model definition, which can simply deployment. Use the second approach here. Note, you previously resized image using image size argument of TerraSuite. If you want to include the resize logic in your model as well, you can use TF Keras layer, resize layer. I think this one is the first layer in our model. Yeah, resizing, yes, rescaling. Okay, it's okay. Create a model. The Kera sequential model consists of three convolution blocks. Okay, this one is with a max pooling layer in each item. There are fully connected layer, dense layer with 128 units on the top of that is activate by ReLU activation function. This model has not been tuned for high accuracy. The goal of this tutorial is shown a standard approach. Okay, here we are using first we want to scale in the last layer. In we are getting num classes, which mean number of classes. These are the length of the classes, which means this one is a 5. So they have 5 outputs. That one is this is output layer. This one is input layer. You are getting rescaling and getting the input. After that, these are the flatten layer is we are using the flatten layer. We are converting our array to 2D to 1D. That's what is that. Compare the model. Okay, this one is always visual using Adam and accuracy. We are comparing the model here. Model.summary. We will get the summary. Okay, trying the model. Okay, after that we will train the model. In here, if we see this one, sorry guys, the accuracy and the validation accuracy are very low, and also it's overfitting. I will show this one. If we okay, if we plot the in the not if we if you see my matplotlib sorry matplotlib video, you can see how to plot these things. These are the simple steps, guys. Not as rocket science. These are things. These are very simple things. Just XY things. That's what. If we plot those things, you can see validation data is another direction, and the training data is another direction. So, uh, sorry. So here the plot show the training accuracy and the validation accuracy are off by large margins, and the model has achieved only around 60% accuracy on the validation set. The following tutorials section show how to inspect what went wrong and try to increase the overall performance of the model. Okay, now we are going to use uh, what we are going to drop some values, and also we are going to use regulation and eliminate this overfitting. That's what we are going to do. I think you'll see in the plot above, the training accuracy is increasing linearly over time, whereas validation accuracy is still around 60% training process. Also, the difference in the accuracy between training and validation accuracy is noticeable, a sign of overfitting. That's what I told. When there are small number of training examples, the model sometimes learns from noise or unwanted details of the training example. To extend its negatively impact the performance of the model on a new example, this phenomenon is known as overfitting. It means that the model will have a difficult time generation on the new dataset. There are multiple ways to fight overfitting in the training process. In this tutorial, we will use data augmentation and drop out to your model. Okay, we studied some things for overfitting and underfitting. Okay, we will check that one. For overfitting, what we are doing here, overfitting, trying here, I thought, we will check. We did some things, man. We drop out. Yes, we did same things. We regularize, and also we will drop some things. I think in the other last one we will drop. Yes, this is the final step we will do. One by one, we got how much the accuracy. So we will get 5. This is the final thing we will achieve. Here also we dropped out some values, and also 0.5 mean 50% of the values, and also we will we sorry we will not we will we used regulation also, so we will get the good value, okay, good, yeah, good summary. Okay, now we will go through this one. Data augmentation. Overfitting generally occurs when there are a small number of training example. Data augmentation takes the approach of generating additional training data for your existing example by augmenting them using random transformation that yield believable looking images, which generate the images first. This helps to expose the model to more aspect of data and generalize better. You will implement the augmentation using Kera's pre-processing layer. Okay, random flip. Okay, they have three main: random flip, random rotation, random zoom. Okay, these can be included inside your model like other layers and on the GPU. Okay, what we are doing then tensor augmentation and Kera sequential. Okay, this is random flip horizontal. Okay, here we are doing we are using three also. All those things. Random flip and all things. I think here we will get those things. Okay, after using this, we will we are going we will sorry we not we are plotting those things in here. Okay, these are the images we got using augmentation. Okay, you will add data augmentation to your model before training in the next step. Okay, we are going to add those augmented photo into our model. Yes, here first input we are getting we are inserting data augmented things. Okay, here is also layers dot rescale. We are rescaling things. These are the previous one same things. We are model in fitting summary. This is the summary. Here we are using 15 approx. Okay, finally here we will see after applying after applying the augmentation and drop out. Yeah, man. Yes, drop out. Yeah, yes. Here we are drop outing 20% of the data also. Right, hydrating. Okay, here we are dropping 20% of the data and also using data augmentation. Finally, we will get I got these two graphs. Here we can see that they have no overfitting. So this is not the perfect one, but this is the shape one like that. Normal. You use your model to classify an image that wasn't included in the training or validation set. Okay, the data augmentation dropout layer inactive in interface time. Okay, now um, we are going to put some we are going to input some unknown photos, which mean some unknown images that are not included in we are training set on also validation set. Then we can check whether this what's that follow that sorry where, what's the flower is that. Okay, here they have this one is given one. Okay, I used another one also. Then we can check how it's work also in last prompt I will show that one. Okay. Here I think this one is not. We don't need to say this one is now. Okay, however, I will read those things. So use TensorFlow Lite. TensorFlow Lite is a set of tools that enable on-device machine learning by helping developers on their models on mobile, embedded, and edge devices. That's what I in the first beginning of the video I told this one. Convert the Keras sequencer model to TensorFlow Lite model. Okay, to use the trained model with the on-device application, first convert it to smaller and more efficient model format called TensorFlow Lite model. In this example, take a trained Keras sequencer model and okay to generate TensorFlow Lite model. Okay, converter. We'll just see this one. Okay, converter, and we will save this one. I think it will here. Yes, this one is here. We can use this model and check our flowers. What's the flowers that one like that? Okay. Run the TensorFlow Lite model. You can access the TensorFlow Lite save model signature in Python via TensorFlow Lite interpreter class. Load the model with interpreter. Okay, like this one, we can load the pre-built model tier. We are sorry, we are loading the model. Print a signature from the converted model to obtain the name of the inputs and outputs. Inter- Interpreter.get signature age. They have some they had some errors in here. I changed those things. I think here that one is error. Yeah. Okay, man. These are the just things. Just we are extracting to a file like model to a file like this one, and we are using it later. That's what here I will upload the code. If you want, you can read those things. Those are not big things. Okay, finally we will upload some images and we will check how our model is working. Okay, now I'm going to say some process. Rosapu, Jinna Rosapu. Okay, what will we do? Should we put this one right? Oh, they have mistakes. Okay, we will upload this one. I'm going to save images. That one is saving some different types. I want to save it into JPEG, man. JPEG. Yeah. Okay, this one is nice. Okay, I'm going to download it. Yeah. Yeah, man. Where is the download? Okay, download. Okay, it's downloading. Okay, downloaded. I'm going to upload that image to here. Is it in connection? Yes. Upload. Yeah, that rows. Okay. Where main? Yeah. Okay, this one is that yellow rose, and this code is I created to input the image. You may have doubt. We can check whether what. Okay, sunflower. Okay, maybe this one is predicting this as a sunflower because I think they have a yellow. That's what it's look like sunflower for that one. Okay, we will check this girl's photo. you may have doubt. We can just see the photos and we can tell whether this one is rose or another flowers. But if we see in our gallery applications, Google Gallery, the galleries automatically predict what our selfies and those things. Like this one, if we predict something, if we model, if we yes, if we develop a model to predict get predict, yes, not predict, to identify the selfie photos, so it will easily search through all the photos and get our selfie photos and put it into an album and show as a selfie album like that using machine learning. I tell you. Okay, we will see this one. Is that JPEG? Yes. For man, it's hotel tulips. Okay, we will check another one also. I'm going to check this time. I'm going to put nice roses. Otherwise, it will not going to give anything. Okay, I'm going to download this one. This is the problem in machine learning things, man. Need to be more accurate, otherwise it will give wrong things. That's what happening in ChatGPT also. That's what the ChatGPT also giving some codes also, error codes like that. We want to try more epochs and like that to get more accurate in models. Mm, it's not. I think this one is process. No, is that okay? I download some process photos. I will check whether it's working or not. Where is process photo? Upload. Where is that process photo? Okay, this one is another process photo. Pixels. I think I am okay. I will check whether there are downloads. Okay, what? Big jumbo like that. Big jumbo with this one. Okay, let me check. Yes, this image most likely belong to process because we are importing the image. TF load the, yeah, we are loading the image. After that I'm converting this to array and I'm adding a dimension to input to model our model. Here we are, this one is model our models. Predict, using a predict, we are input that array into here and we are getting the prediction. After that we are showing the prediction score and also which belongs to which class, like that, man. Okay, thanks for watching this video. Maybe I am struggling with English, but I think I will improve as much as quick. So please support these videos, guys. Okay, bye.